Hello all, welcome back to CAD Technologies. Today we'll be seeing an example about an assembly module. As you can see on the screen, this is a V-block assembly which we'll be learning how to make today. There are two different types of drawings provided usually in assembly, a composite drawing and a simple individual part drawings. A composite drawing basically is a combination of the assembly as well as the part drawings, whereas part drawings are just about the part drawings. Like if I scroll down to the next page, these are my part drawings. So the page 2 and the page 3 are usually part detailing, but when you combine it with the page 1, it becomes a composite drawing. Composite drawing is usually a combination of both, which is a part drawing as well as the assembly drawing. Now, coming to understanding the view on the screen, this is called an exploded view. An exploded view usually helps you understand how to assemble the components in the on the screen. This is called the bill of materials table. Bill of materials table on my drawing usually comprises of three columns: serial number, part name and quantity. It can be of more, you can give material, you can give different options of different parameters to the bill of material table as well. Now I have three serial numbers, which is 1, 2, 3. The first one is bolt, which is of quantity 1. The second one is clamp, which is of quantity 1. And 3 is V block, which is of quantity 1. If you have more quantities, the quantities will auto change in the bill of material table. Now, understanding this, first is the base, which is a V block. This particular clamp is going to be inserted into this groove of the V block, and the bolt is there to join them together. Let's begin how to make this. First we'll see how to make a V block, and then we'll see how to make a clamp, and then we'll understand the bolt, and then in another one we'll see how to make the combination or the assembly of the same. So let's begin by making the V block first. I'll keep them in one single playlist so you can understand how they work. Now let's begin by making the first one, which is a V block. Since it's a part design module, I'll just go into the part design and start making my sketch. The first one is actually of this, which is of 48 and the overall height is 51. So let me take a rectangle. I would like to add this to 72. Now, I'd like to do it symmetrically, as in mirrored extent. The reason is this particular clamp is exactly located at the center. There is a movement in this direction. So if I keep it at the center, I will have a plane exactly at the center, so I can assemble this and keep it exactly at the center location. So let me try to add the material, which is 36, mirrored event on both the sides. Now, as you can see, let's start removing the material. We know pocket is used to remove the material. A very simple sketch is what I'm trying to make, and then I join these. And give the dimensions. The distance from the end to this is actually 21. And this distance is given as 4. The overall height is given as 13. And the distance from the corner is also given as 13. till here is given as 30. Exit. Now if I remove the material, it removes the material till wherever you like. I want it to up to the next, so it tends to remove it till there. Now I cannot mirror this because they are two of different shapes. So I'd like to again take it separately and then go ahead with it, with understanding this as is my reference. I'll take the same shape as you can see, and then mirror it like how we have done a little while back. Now the distances. The end to end distance is 36, which is already given. So I'd like to give the 36 here. And then I have the overall height, which is 21. And these are in line with the bottom face. I do not want to repeat the dimensions, so I'll just coincide them. And this is 21, this is 36, symmetric, perfect. Now, this is 4 as well. It's 4 typical, so I'd like to give this as 4 too. Now, once I exit, I'll have to remove the material. I'll remove it up to the next. I'm making this cut as well. So let's try to do that. Here you can mirror the cut. There is no issue with that. We know this is 4 and this is 9. And then mirror it onto the opposite side. We require the same feature onto the other side, so mirror it onto the opposite side. Now we'll save this as the V block because we need the V block. We'll save this. Now, the next component is making the clamp. So let's try to start making the clamp as well using the same part design. Now I'll start with the front view. I have a rectangle this way. We can add this later, or let's begin by making the whole shape if possible in one attempt. So let's try to make the sketch under your pad and follow the process. This is my 30, so let me try to take 30 first with respect to the center. 30, and then you can go to the left and then go down and then close it, and then I'll mirror the whole thing onto the opposite side as well and make this horizontal. Now let us give the dimensions. We know that this height is 30, so let's try to follow that, and the overall distance is 66, so you can give 66 as well. Again, I'll do a symmetrical addition of material because as I've already told you in the drawing, I want them to be exactly at the center. So since it's supposed to be 18, I'll give 9 and then say okay, add the material. Now let us add this feature next, which is at a distance of 64. I'll take a plane towards the opposite side to 64. You can directly drag it as well, there is no issue. On this we are trying to create the addition of material. Let's try to create the addition of material. Our references are these two ends because they have to match with the ends. So let me try to take this end as well as this end as our references, and then now proceed further with our sketch. The sketch should be exactly at the center, which is of 18. So I can take a center rectangle and then give it as 18. Now since it's not coincident, I'll use the constraints which we have seen. The length of this is supposed to be 18. This is added towards the body and up to the immediate next space it can find. Now as per the drawing, let's try to remove the material as well. So let's use the pocket to remove the material. I have this reference only, which is the center, so I can directly take that as the center and give R18, no issues at all, or you can maintain concentricity. Now, the shape somewhat goes like this, goes down, cuts till a certain extent and then comes down. This should coincide on this. I haven't taken that as a reference, so I'll just directly coincide them together and keep it. Let us finish the dimensions. Let us mirror these first and then finish the dimensioning part of it as well. Overall end to end distance from here is 40 and the above is actually 48. And the length is 9. This is 9 as in this drawing, that means it slides through this portion. Again exit, cut the material up to the next. We have a hole as well which is 12 through, so let's try to give that too exactly at the center. Again I'll coincide using the coincide constraint to the center. Coincide this to the center. I have coincided it wrong last time. Now exit the workbench and then give it as 12. It says up to next, so I'll give it up to next and then say okay. Let us give the small round which is R3. I'll just select the edges to give the R3 and then give it as 3 and say enter. It gives the rounds. This is the clamp. Let us save this file and then proceed to make the bolt. This is the drawing of the bolt. We can make this since it's controlled by its diameter, we can use the shaft command. We can also make this in one attempt, or you can use feature based model and do it one step after the other, whichever is flexible for you. So let's just start making that directly by using your shaft. We know the center of axis is this, so I'd be using that as my center of axis. And then I'd like to make my sketch. Now if you're trying to make it directly, you can do so by directly taking it this way. And create a shaft after giving the dimensions. Or if you want, you can go ahead with feature based modeling, which you can directly take the whole rectangle in one attempt and then start removing the material one step after the other using your groove command. The first one is better for me, so let me try to do that only instead of going ahead this way. The shape somewhat looks like this, and let me close the profile. Now you can start giving your diameter dimensions, as we already know how to use this, so we can just directly give the dimensions. This is 21. We know this dimension is 12. We know the bottom dimension is 9. Heights, coming to the heights, the length of this is 15 and the bottom length is 15 as well, and the overall is 70. Now once you exit, it will directly create the shaft and give it for you. Now last, you have a chamfer operation over here, so you can directly use a chamfer operation and then just select the edge and then give whatever this is 1.5. So let me take the 1.5. This is your bolt. This is your exploded view. In the exploded view, I'd like to place the V block first and then do the clamp and then the bolt. So first, to place the V block, let us call the component and do it one after the other. Let me try to insert the component. Let us enter into the assembly workbench. I'm already in my assembly workbench. You can go to start mechanical design and use your assembly design. Now you can call the component by either using existing component or existing component with positioning. Either one is better. Now I'm trying to call the first one. So the first one is V block, and then when I say open, you can see the V block. While doing the assembly, you have to constrain all the 6 degrees of motion. So this one is, since it's a first component, I'd like to fix this. So once I fix the component, what will happen is I can continue by giving, with respect to this component, I can continue giving other constraints to the remaining parts we have. So first let us fix this component, and when you click on right click and see the feature and you see component degrees of freedom, it will show you that there are no degrees of freedom. We have to restrict the degrees of freedom. Now the second component is the clamp, so I'll be calling the clamp. Now I'd like to place this, let's just say automatic rename. Now I'd like to place this. Let me try to move this first instead, or I can just move it however I want to. I'm dragging it in x-axis right now. Now let me constrain this. Now I'd like to constrain the center to the center first. Now we do know that this should be inside that, so let us try to do that as well. We can fix this on top of this should be fixed. Okay, yeah, this should be fixed on top of this. This is your first constraint, and then the other one should be, that's not the constraint, sorry. Let me give the coincide constraint of this into this face, which is the first one, and then I have the bottom face to be fixed there. Bottom face to be fixed over here. This face. Now, once I say update, which is Control U, it automatically places itself there. This is your first one. Now, you can check for the component degrees of freedom. It shows you that there are no component degrees of freedom. Now, the last and the last component to place for the assembly is actually called your bolt. So let me try to take the bolt. It just directly comes onto the screen. Now, once it's over here, let me try to move this. Now again start constraining. This should be in line with this face. So let me try to coincide the axis as well as the axis. When I click on Control U, it auto updates and goes there. Now when I'm trying to give the movement, I'll try to give the movement with respect to the axis. So I can only move it via Z axis. Taking the front view, it's understandable that this should not coincide on the body. So we can give a distance constraint between these two. Let me try to move it to a certain extent. It's okay till here, it will not coincide. So let's try to give a distance constraint in between this face and this face. The distance is actually 6.23. I'll like to give it a 6. So and then say Control U, it gives you this. This is how you create an assembly in CATIA. As you can see, they are not coinciding. You can go back to your isometric view and also see the picture. This is how you do an assembly using CATIA, which is a V block assembly. We have drawings as well. We have made one part and the other and then assembled them in one single workbench. This is called your assembly design. If you want to work on more complex components, you can contact us for training purposes. We'd be happy to help you. Our details are given in the description below. Meanwhile, like and subscribe to our channel so it gives us a lot more support to do more videos like this which might help you out. Thank you.